Hello, I'm Uwe Bergmann. I'm a X-ray scientist at SLAC National Accelerator Laboratory. SLAC is a DOE laboratory operated by Stanford University, and it is specialized on accelerator technology. It used to be a mainly particle physics lab, and now it operates the world's first X-ray laser and also a large synchrotron, in addition to several other science programs, including still also particle physics. I got started in STEM as a maybe teenager. I had some friends and we were very fascinated with questions about physics and how nature works. I think it was this friendship and this small group of people who met in the afternoon, which really got my fascination for physics, which was also what I studied in college and also in graduate school. As a child, I was always absolutely fascinated with nature. I had a grandpa who gave me encyclopedia about animals. Animals was really what I liked, but then I quickly learned about how everything is connected, and in the end I believe that my research, which I've been doing for the last 25 years, brings all of this together. I started out as I said, in physics, but now I have been specializing on developing new X-ray methods. These are methods which are using these X-ray lasers and also powerful synchrotron radiation, and the application of those tools is very broad, and that includes, in my own case, the study of water. For example, we have been for many years trying to understand what, 3 is a glass of water, so what holds these water molecules together, how are they structured, and you might not believe it, but there's still a lot of unknowns. Water is such an incredibly unusual substance that we still have to learn a lot about it. I have been using X-ray techniques to study also how water is split in photosynthesis, which is, of course, everyone has heard about it. The sun does that, and it has created essentially all the oxygen in our atmosphere, and without this oxygen in our atmosphere, a complicated, complex life like ourselves, and also, but even most other complex life forms which are based on respiration would not have been able to evolve. And we are using X-ray lasers, and we are now starting to make really movies of the molecules and of the atoms, how they really carry out this a very, very important reaction where two water molecules are brought together and then an oxygen O2 molecule gets evolved. And another really field I have been spending a lot of time with over the last 12 years or so has been to use synchrotron radiation to image and read ancient documents, to bring them to light, and also to look into the chemical composition of fossils. And the whole work started with a project called the Archimedes palimpsest, which is a very famous old book. It was a prayer book from the 12th century, written by a Byzantine monk. And this monk, as many others did at the time, had actually used parchment leaves with other writings and then washed off and erased these writings and reused the expensive parchment and wrote his prayer work on it. And in this particular case, these leaves contained the oldest copy of work by the Greek genius Archimedes, and because they were overwritten and because they were washed out, it wasn't possible to read them before, and with these x-rays we were able to bring them to life. What really inspires me about my work, I would say more than anything else, is the collaboration. In our field, we do collaborations around the whole world, within the US, but also within the whole world. I have collaborations in France, in Germany, in Sweden, in Japan, in Korea, and bringing a lot of scientists together to figure out a big problem is just wonderful. It's like, it is unbelievable. And I believe that the synchrotron, which is a large X-ray facility, and it's really like a big lab, brings all these people together. And when you go down the floor and you walk around, even though you do your own experiment on a very specialized topic, you can see researchers from so many different fields, and this is also very, very inspiring. And if I go back to how all started for me, I can see it coming full circle actually, because originally when I was a little kid, I didn't think so much about physics, and but now I realize that you can use physics tools and you can use the understanding of physics to actually answer questions in many fields, and that widens your horizon, and that just continues to inspire your curiosity. And I believe that this is generally something which is true for if you get an education in STEM, because even though you might end up doing something rather different than what you learned when you were a student or in high school, which is quite normal, you build up a basic understanding and a basic fundament of knowledge, and then you can apply this knowledge and you can apply this thinking to many things. So for example, right now in this crisis of coronavirus, it's good to know what an exponential function is. It's good to know how the structure of a virus looks like. It's good to know, and you can, if you have a STEM background, you can read these and you can really put things together. And then it also makes you better understand why you have to do certain things and why you shouldn't do other things. So being educated in STEM, I think, makes you creative and well-informed individual. Now, in my free time, I really enjoy nature, and so one of my favorite things, which I do with my wife, we go down to the Monterey Bay and we go kayaking through the kelp forest and looking at the amazing wildlife you can see there, including seals and sea otters and sea lions, and if you're lucky, sometimes you see a whale or some dolphins. And I also go scuba diving and free diving and snorkeling. We have been at a few of the really wonderful coral reefs, and to see the diversity of nature, there is nothing which to me is more inspiring to see the art and the beauty and the complexity which nature can offer. And a coral reef is really a place of magic. We do have a Twitter handle at Slack. It is called Slack Lab, SLAC Lab, and I hope you consider choosing this field, and I hope you are inspired, and I wish you all the best. Stay safe, stay healthy, and have a great future. Thank you.